Oh, hi guys, this is Dr. Diaz, and here's another example of three resistors in parallel. This is the one from the PowerPoint, and I'm going to show you this example before I go to Kirchhoff's law, and the problem's already solved. So look here, look how it goes. Three resistors connected in parallel, as shown. Here we have the three resistor. The potential difference is 18 volts, which is the source. And the first thing it says is calculate the equivalent resistance. Since all three are in parallel, this is going to be 1 over 1 over 3 ohms plus 1 over 6 ohms plus 1 over 9 ohms. That's what they did here. 1 over 3, 1 over 6, 1 over 9, and they get 11 divided by 8. Then they do the reciprocal. That's what they did with the equivalent. And they get, well, 1.64 ohms, which is actually true. I mean, well, of course they did it properly. But look, the equivalent, because they're all in parallel, is going to be smaller than the smallest of these three. You can see the smallest is 3, and the answer was 1.6. Next. Now, they're going to ask us to find the current in each resistor. So let's go back for a second. When the current goes here from the positive side of the battery, and it travels through this junction here, the current has 3 pulsable paths because there are 3 resistors. They're all in parallel. So part of the current will go here, part will go here, part will go here. But before we found how much it went here through resistor 1, 2, and 3, we need to calculate the total current. Since we have the total resistance, or the resistance equivalent, and here with the total voltage, then we use Ohm's law, that it says voltage is equal to current times resistance. We solve for current, and we have voltage divided by resistance, which is 18 volts divided by 1.64 ohms, and the total current is 10.97. We can say this is 11 ohms. 11 amperes. Sorry about that. So we know the total is 11 ampere, but how much it went through 1, 2, and 3? Since, according to Ohm's law, current will be voltage divided by resistance. In this case, I1 is going to be equal to R1 divided by, V1 divided by R1. And I2 is going to be V2 divided by R2, and R3 is going to be V3 divided by R3. These. But because they are in parallel, let's go back a little bit. They are in parallel, that means that the voltage at this point, A and B, is the same. The voltage for the 3 ohm resistor and 6 ohm resistor and 9 ohm resistor, because they're in parallel, is going to be the same. That's why here in the equation, instead of putting here V1 and here V2 and here V3, they're using the total voltage, which is V, 18 volts. So 18 volts divided by 3 ohms is 6 ampere. 18 volts divided by 6 is going to be 3, and 18 volts divided by 9 is 2. And if you add these 3, the total is going to be 11, which is the total current of the system. Now, another interesting question that they asked in this problem is, how much is the power? And we haven't discussed that yet, but I give you a slice, and isn't the slice in the PDF? But here is power is equal to current squares times resistance. Also, you can write here in terms of voltage. Well, let me go here for a second. Oh yes, what I was saying is that power is current square times resistance, or voltage square divided by resistance. So you can use one of those two equations, and actually I think it's in the formula sheet. Like I said, power is equal to current square times resistance, or power is equal to voltage square divided by resistance. But in this case, we're using the current, which is much easier, and we have, well, the power in the resistor of 3 ohms is going to be what? I1, which is 6 ohms squared, 36 times 3, 108 watts. The power in the second resistor of 6 ohms is going to be what? It's going to be I squared, which is 3 squared is 9, times 6 is 54. And the last one is going to be power in the 9 resistor is going to be I3 squared, which is 2 squared is 4, times 9 is going to be 36. And that's it. The second later I'm going to discuss about Kirchhoff's law. Take care, guys.